So let's recap on that. The major axis runs through the focus points, and the major axis then here is horizontal, which means it's parallel to the x-axis, which means that the a value or a squared value goes underneath the x squared value, and the b squared value goes under the y squared value. Let's move on to the next problem here. We want to find the equation of the hyperbola with the center at -5, 0, one focus at -5, 3, and one vertex at -5, 2. Once again, I think it's best if we draw the picture and try and understand the equation based off the picture. Okay, so these points tell me a lot about the hyperbola. First of all, the vertex at -5, 2 is going to be faced, we have a parabola faced up, because remember that the focus is within the cup of the parabola. This tells me a lot about the equation of the hyperbola. I know that I'm going to have a hyperbola that has the a squared underneath the y squared, because the major axis, which goes through the center, the vertex, and the focus, that major axis runs parallel to the y-axis. So I'm going to be using this equation here. So this means that I need to figure out a squared and b squared. I have h and k. A squared, we have that already. A is the distance from the center to the vertex point. The distance is 2 there. That means that a squared is 4. Now I have the distance from the center to the focus, which is 3. C is 3, which means c squared is 4. I'm sorry, c squared is 9. Because I have a squared and c squared, I can figure out what b squared is equal. I've manipulated my equation, and I've plugged in c squared and a squared, and I have that b squared is 5, which means all I need to do is plug everything in, and I have my equation. Alright, so okay, so here we have our equation, and that's it. Okay, number 9 here. Graph the hyperbola by showing the asymptotes crossing the diagonals of the rectangle. Find the equations of the asymptotes. Let's go ahead and graph the hyperbola and have a visual that helps us to understand what those equations should be equal to. Okay, let's start off by plotting the center. -3, 4 is our center. And from here I want to construct my rectangle. So because the x squared is over the 9, that means I'm going to go out horizontally from my center and plot my a values. Okay, so I go out 1, 2, 3 to here, and I go out 1, 2, 1, 2, 3 to here, and that gives me the a value for the slope of my asymptote. And from here, from the center, I'm going to go up 2 and I'm going to go down 2. This gives me the rectangle that will enable me to draw the diagonals of that make up the asymptotes. Okay, so here I have my asymptotes drawn, and now I can draw my parabolas, which make up the hyperbola. The parabola's vertex points are here in blue, and our parabolas are facing outward like so. And the reason I know that is because the major axis in this case is parallel to the x-axis. because the a squared is underneath our x squared value. So from here, I want to find the equations of my asymptotes. And remember that the equation of a line is represented by y equals mx plus b. And so I'm going to go ahead and figure out the equation of the asymptote first that's positive. So this one right here. Let's figure out the equation of that particular asymptote. Well, the slope of that asymptote, remember that we find the slope by the rise over the run. So I go up a distance of 2 from my center to that b value, and then I go to the right a distance of 3. So my slope is 2 over 3. That's my slope. And I need to figure out the b value. Remember, all we need for slope-intercept form is the slope in the intercept. I don't know the b value. I can only speculate as to what it is. So what I need to do is plug in an x and y to solve for b. Really, we could actually figure out how far we've gone over, but I'm going to show you guys algebraically how to do it. Plug in a point. We're going to plug in the center of the hyperbola because that point is on our asymptote. So we're going to plug in when y is 4 and x is -3, and we're going to solve for the b value. Okay, solving for b has given me a 6. And that was a pretty good estimate of the point there, and of the y-intercept, I should say. So here we have one equation of our asymptote. We need to figure out the other equation of our asymptote, and the other equation has a negative slope. The other equation, we have a slope, this asymptote that's falling from left to right. And the difference is that our slope now is negative. So that is going to change our problem by now giving us a positive 2 here. And then if we subtract 2 to both sides, that's going to give us a b value of 2, which means that our other equation is y equals -2 over 3x plus 2. Which is going to give us both the equations of our asymptotes. And voila, we're done, finally. No, we have one more problem. It's not a conic problem, though. We have problem 10, which means we need to figure out how to graph a point on a 2-dimensional space, a 3-dimensional point on a 2-dimensional space. It means that we're going to have to set up this modified axis system, and we have the plus x here, we have the minus x here, we have the plus y here, and we have the minus y here, we have the minus z here, we have the plus z here. And in order to graph this point, we have to show all the points of the rectangular prism. So that means that I'm going to have to show the point 0, 0, 0. And I'm also going to have to show the points that lie on each axis. So I'm going to have to show 2, 0, 0. I'm going to have to show 0, -3, 0. And I'm going to have to show 0, 0, -4. Let's go ahead and start off with the easiest point here at 0, 0, 0. Next one here I'm going to show is at 2, 0, 0. So I'm going to go out a distance of 2 on the x-axis. So I'm going to make my interval marks parallel to the y-axis because I want to create this visual of a 3-dimensional shape. So I'm going to plot this point right here, and that is at 2, 0, 0. Next point here, I'm going to plot at 0, negative 3, 0. That's the y-axis, so I'm going to make some interval marks that are parallel to x, and that gives me a point here of, we have 0, negative 3, 0. Last point here on the axis, let's plot 0, 0, negative 4, 0, 0, negative 4. It's this point right here. Now from here, let's go ahead and start making the sides of the rectangular prism. I'll go ahead and start with the XZ plane. So we're going to essentially create the two-dimensional sides which make up the three-dimensional shape. So to find the point connecting the X and Z plane, we're going to go down from X parallel to Z, and we're going to go out from Z parallel to X, and that gives me this point right here, which is 2, 0, negative 4. Okay, let's go ahead and connect our YZ plane. So from my y-axis, I'm going to go down parallel to Z, and from my z-axis, I'm going to go out parallel to y. And that gives me this point right here, and that point is at 0, negative 3, negative 4. Alrighty, so let's go ahead and let's make the top here. And so I'm going to go from y, I'm going to go out parallel to x, and from x I'm going to go out parallel to y. Uh-oh, not looking that pretty. Okay, there we go. And so this point here is 2, negative 3, 0. And things are starting to take shape here. I can make the rest of my rectangular prism by going down parallel to Z. From here I'm going to go out parallel to Y. From here I'm going to go out parallel to X. And that gives me my point there, which is 2, negative 3, negative 4. And that's it. Make sure you guys study. If need be, watch the video several times and work through the problems several times, and you should be more than prepared. I promise you that. Okay, see you tomorrow. Good luck. May the force be with you. By the way, you can thank Andy for this one. He sort of inspired me to make me do this. All right, so thank Andy.